Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. I have brought a series for ISI and CMI preparation. In fact, my today's topic is problems on functional equation and composite of functions, which is equally important for JEE Advanced as well. So let us start our session with this problem where we are asked to find all continuous functions that satisfies the relation f of fx plus x is equal to 0. Now to do such problems, what we will do, we will replace, in fact here it should have been given for all x. Okay, so here what we will be doing as a very first step, we will be replacing x by f of x. And if I do so, then my equation will become f of fx, where f will be taken 3 times, plus f of fx plus fx is equal to 0. Now what will be the advantage of doing this? You can check that these two terms are same in equation 1 as well as in equation 2. So if I take the difference of 1 from 2, you can check f of fx 3 times fx will be equal to x. Okay, let me call this as equation number 3. Now, I think it is very much obvious to say directly that fx is equal to x is a solution of equation number 3. Isn't it? Because f of x is equal to x means f of fx will also be x and f of fx 3 times will also be x. But if I put in equation number 1, f of x is equal to x, then it will give us x, because if fx is equal to x, f of fx will also be x, and then x, again x is equal to 0, which gives us x is equal to 0. So even if this relation, this equation, this solution fx is equal to x, if we assume that is a solution of this given equation number 1, this will be valid only for x is equal to 0. So it cannot be a continuous function, because you will be just having a dot at x is equal to 0. So that is not a solution for equation number 1. So what can be the solution for equation number 1? Now please listen carefully. We have derived equation 3 from equation number 1. So whatever solution of 1 will also be solution of 3. But converse may not be the true. We may get a solution for equation 3, but that may not be equation of 1. But whatever is the solution of 1, it has to be solution of 3. So here we will try to find more solutions for f of fx is equal to x, because it seems easier to solve, and we will try by putting that whether they are solution of equation 1 or not. Now to do this, what I am going to do next, I will try to find whether fx is 1 or not. Actually we are already given continuous function, so continuous function in combination with 1 or many 1, we may be able to conclude many other things also. So here please see, if I take x1 not equal to x2, but we assume that f of x1 is equal to f of x2, which is one very standard technique to find whether a function is 1 or not. Then what we can do, we can take one more times, because f of x1 is equal to f of x2, then f of fx1 has to be equal to f of fx2 also. And taking one more time, f will also be equal to f of fx2. But these things from equation number 3 has to be x1 and x2, and hence x1 should become equal to x2. So what you can see, whatever we took in the beginning, we got a contradiction of that. So we can conclude that f of x1 will be equal to f of x2 only if x1 is equal to x2. That means this fx has to be 1, and because it is continuous, so what conclusion can be drawn from this? I think the important conclusion from this is that this fx has to be strictly increasing or strictly decreasing. So this fx has to be strictly increasing or strictly decreasing. Why I am saying so? Because if it is not strictly increasing or strictly decreasing, but it is combination, or you can say it is sometimes increasing, sometimes decreasing, so it has to have some point of maxima or minima. Then about that point of maxima or minima, there will be some x1, x2 which are different, but f of x1 will be equal to f of x2, which is not possible as we have proved here. So this will be either strictly increasing or strictly decreasing. Now, if I take f of x as strictly decreasing, then you can see f of fx, I think this is direct, you can conclude from this, 3 times composite of a decreasing function has to be decreasing only, because decreasing of decreasing will be increasing, and then again take composite with the same function, it will become decreasing, but on the right hand side it is equal to x, which is increasing function. So it seems it is not possible, which can be proved otherwise also. Please see how. That take x1 greater than x2 and fx is decreasing, then f of x1 will be less than f of x2 because it is decreasing function. Now if I take one more times f, so f of fx1, now once again this sign will change, it will be greater than f of fx2, and if I take one more time, then again that sign should change. So f of fx1 will be less than f of fx2. Okay, and here because of this equation number 3, you can see we should get x1 less than x2, but you can see we started with this thing and we ended with the opposite thing. So that means fx cannot be strictly decreasing, can't be strictly decreasing, so it has to be increasing. So fx is strictly increasing only. Now strictly increasing can be justified directly also, because increasing, if you take composite 2 times or 3 times, it will still be increasing, and on the right hand side again we are having x which is increasing. Now we have already checked that fx is equal to x was a solution, but that was not the solution of this equation number 1. So is there any other solution than fx is equal to x for equation 3? So we will assume let there exist some x1 such that f of x1 is either greater than x1 or it is less than x1 and function is strictly increasing. Then if I take f of fx, okay, because it is strictly increasing, sign will remain same. What I have done, I have taken f on both sides, or in this case it will be less than f of x1. Okay, and if I take one more time, so f of fx1 3 times will be greater than f of x1 actually. And this thing is nothing but x1, so it will be greater than f of x1, and f of x1 is greater than f of x1. So what we started with, you can again see we got a contradiction. We started with f of x1 is greater than x1, but we got x1 greater than f of x1. That means fx1 greater than x1 is not possible. Now same thing can be done here also. If you take f of fx1 2 times, sign will remain same because function is strictly increasing. Once again, if I take one more fx, f of fx1, it will be less than f of x1, but this is x1, so x1 will be less than f of x1, and in this case we took f of x1 is less than x1. Okay, so this f of x1 will be less than f of x1. So once again you can check, we started with f of x1 to be less than x1, but we got x1 to be less than f of x1. So that means f of x equal to x is only solution of equation 3. But as we have proved that this is not the solution of equation number 1, so that means there is no function, there cannot be there cannot be any function, or rather any continuous function that satisfies equation number 1. That satisfies equation 1. Okay, so this completes the solution of this question. Now coming to next question. This question says there is a function fx that satisfies f of x plus 1 is equal to 4 times fx into 1 minus fx, and number of possible choices of f1 such that f of 2022 is equal to 0 is k. Then find the sum of digits of greatest integer part of log of k base 2. Okay, now everybody please see, here we are given one relation that f of x plus 1 is equal to 4 times t into 1 minus t. If I call this fx as t, then it will be like this only. Now if I draw a graph of this right hand side of this equation, let me call this as t curve, t axis, and this as y axis. So if I draw a graph of y is equal to 4 times t into 1 minus t, you can see it will be a downward parabola whose roots are clearly seen as 0 and 1, and its maximum value will occur at 1 by 2. Okay, and the value, maximum value at 1 by 2, you can check, it will be 1. So this is what we are getting for this expression. Now let us try to do this question. We are given that f of 2022 is equal to 0. So in this given equation, I think this is also 1. So in this equation number 1, if I take x is equal to 2021, okay, so you can check that f of 2021 will be either 0 or 1. Let me repeat it once again. If x is 2021, this will be f of 2022, which is 0. Then f of 2021 will be either 0 or it will be 1. I hope that is clear. Now again, using this equation number 1 and take x as 2020, take x as 2020, then this f of 2021 will be 4 times f of 2020 into 1 minus f of 2020. Now here there are two cases. One is that this can be either 0 or this can be 1. Okay, now if it is 0, then you can see f of 2020 will be once again either 0 or 1. But if it is 1, if this f of 2021 is 1, listen carefully, this expression can take maximum value as 1. Okay, so if I call this as 1, so this will be possible only if f of 2020 is equal to half. You can check. If this is 1, it will become actually perfect square. You can solve that way also, but I am trying to tell you through graph that this is a downward parabola whose maximum value is 1 at x is equal to or t equal to half. So if I take this as 1, so this 1 will be possible only if we take f of 2020 as 1 by 2. Okay, so what you can check that for this f of 2022 equal to 0, we got f of 2021 having two values 0 or 1, and then for f of 2021 we are getting, for 2020 we are getting three values 0, 1 or 1 by 2. I'll now go to the next slide. Okay, let me take a separate slide for this. So what we have done so far, that we have proved that if f of 2022 is 0, if f of 2022 is 0, then we are getting f of 2021 taking two values either 0 or 1. Okay, now if f of 2021 is 0, with that same logic for this 2022, it will be either 0 or 1. In fact, for the 0, we are getting two values. But for 1, we are getting only one value, that is 1 by 2. This I proved in this slide here. Now, listen carefully. Same way, if I proceed, f of 2019 will be corresponding to this 0. It will take two values, either 0 or 1. But for 1, it will take one value, that is 1 by 2. Now coming to this 1 by 2. Now please listen carefully. Once again, if I take f of 2020 as 1 by 2, I think I'll be getting 4 times f of 2019 into 1 minus f of 2019 is equal to 1 by 2. Now please see, I'll try to solve this using the graph. Now it is like 4 times t into 1 minus t is equal to half, and we are looking for what will be my t. So if I draw a line parallel to x-axis, whose equation you can call as y is equal to half, okay, you can see we will be getting two values of t. We will be getting two values of t. You can call this as alpha 1 and alpha 2. Okay, and these values are different from 0, different from half, different from 1. So here what I am trying to say, that for 1 by 2 there will be two different values of this f of 2019, and this will be alpha 1 and alpha 2, let us say. Now once again we have got f of 2019 which is having 5 values. Now for 2018, I think after that I'll be able to tell you the pattern. This is 0 or 1 corresponding to this 0, and corresponding to this 1, this will be half only. For corresponding to half, it will be alpha 1 and alpha 2. Now question comes that if f of this 2019 is alpha 1, okay, it is like solving for this 4 times t into 1 minus t is equal to alpha 1 or alpha 2. Now please see, this alpha 1 value is definitely between 0 and half. So if I try to draw a graph of y is equal to alpha 1, okay, it will be lying below y is equal to half, and corresponding to this, the values of t that we will be getting will be something different. Let me call this as beta 1, beta 2 here. Okay, and similarly corresponding to alpha 2 was greater than half but less than 1. So if I draw a graph for y equal to alpha 2, you can check corresponding to this, the values of t will be different from what we got as beta 1, beta 2. It will be beta 3, beta 4, let me call this as. Okay, so what we have got here, that corresponding to this alpha 1, there will be two values, beta 1, beta 2. And for corresponding to alpha 2, there will be two more values, beta 3 and beta 4. So what you can check, that starting with this, there was only one solution, one value for f of 2022, but for 2021 we got two values. Then for 2020 we got three values. Then for 2019 we got, I think, 5 values. 2019 we got 5 values. And now for 2018 we have got 7 values. Actually we are getting for every value of f, the next value is giving us 2 values except for this one, because this one will be giving us only one value, that is half. Okay, here the way I have told you, that for alpha 1, alpha 2 we are getting 2 values each. For beta 1 also we will be getting next time 2 more values. For beta 2 also we will be getting 2 more values, and similarly for beta 3 and beta 4. Okay, so if I summarize it, or let me write the pattern. Let me write the pattern for F2021. Let us start with this. We are getting 2 values. Okay, and then for f of 2020 we are getting 3 values. Okay, then f of 2019 we are getting 3 into 2, 6 minus 1, 5 values. and then f of 2018 we are getting 9 values. Let me call this as n, that is number of such values. Okay, so you can see every time what we are getting one less than the twice of previous value. Okay, so I think it can be written like f of n r is equal to 2 times fn r plus 1 minus 1. You can check this number is decreased by 1, and for this decreased value of this r, the number of such values are 2 times the previous value minus 1. So what I can write this as fn r minus 1, it is like recurrence method which we discussed in R1 of session. You can go through it. So this is what we are getting, that f of n r minus 1 is equal to 2 times fn r plus 1 minus 1. So I can say that fn r minus 1 will actually be 2 times, you can say, or let me do one thing. Let me go this till 1 only, because we are looking for 1. So I think this will be equal to 2 raised to the power. From 2021, I have to do it 2020 times. I think 2000. Let me think once again. For 2021, it will be like, if I write it like 2 power 0 plus 1, we can write this. I can write 2 power 1 plus 1. This I can write 2 power 2 plus 1. So this f of 1 will be 2021, I think. Yeah, fn1 minus 1 will be 2 times 2 power 2021. Actually, I could have put r is equal to 2021 here, and that way also we will be able to get this as 2021 in the power of 2. So here number of such possible values for fn1 will be 2 raised to the power 2021 plus 1. So this is actually the value of k. So if I take the log to the base 2 for this k, I think the GINT of this will come out to be 2021, because this will be slightly bigger than 2021, because adding 1 will not change the characteristic, it will only change the mantissa. So the GINT value of this will be 2021. So the sum of all the digits of this will be, let me write the answer here, the final answer, it will be 2 plus 2 4 plus 1 5. So this completes this question number 2. Now coming to this question, in which we are given f n to n is a function such that f of n plus 1 is greater than fn, that means function is strictly increasing, although domain is natural number which has discrete values like 1 2 3 and so on, but here f2 will be greater than f1, f3 will be greater than f2 and so on. So values will be in increasing order as you go from f1 to f2, f3 and so on. And also we are given that f of fn is equal to 3n for all n. Now we have to find what will be f of 2022. Now one very interesting problem, let us see how to do this question. Now to do this question, first I will like to find that what will be my f1. So if I put n is equal to 1 in this given equation, then let me call this as equation number 1. Then I will be getting f of f1 is equal to 3. Now we can now guess that f1 can be equal to 1 or 2 or maybe higher value. So if I take f1 is equal to 1, you can see this equation, let me call this as 2, will give us f of 1 equal to 3, because f1 if it is 1 and if I put it 1 here, then f1 will be 3, which is not possible, because you cannot have in a function f1 to have two values as 1 and 3. So this is not possible. Now if I take f1 to be equal to 2, then this f of 2 will be equal to 3. Now seems fine, because f1 is 2, f2 is 3, it is increasing, so that seems fine. But what if there is some more possibilities, like f1 if I take equal to 3, then I will be getting f of 3 is equal to 3. But as you can see, if f1 is 3, my f2 has to be greater than f1 and f3 has to be greater than f2. But then how it is possible that f1 and f3 become same? So that is also not possible. And same way it can be checked that if I take f1 is equal to 4, then I will be getting f4 is equal to 3. Okay, but it is definitely not possible because f1 being 4 and f4 being lesser than 4, that is not possible because our function is strictly increasing. So this is not possible, and similar way I think other values are also not possible. Hence I can say my f1 has to be equal to 2 only and f2 has to be 3 only. So I think these two things at least we have found. Okay, now there is one more thing I will do, that is the similar thing what I did in our first question, that if I take f on both sides of this equation number 1, I think we will be getting f of fn, and that will be equal to f of 3n. Now this left hand side can be thought of as if we have replaced this n by fn. So this left hand side will become 3 times fn is equal to f of 3n. So what we have got here, that f of 3n is equal to 3 times fn. I think this is going to be very helpful in big way. Please see how. I'll call this equation as 3. Okay, let me go to the next slide and let me write whatever we have got so far. We have got f1 is equal to 2. We have got f2 to be equal to 3. And we have got f of 3n is equal to 3 times fn. Now, if I put n is equal to 1 here, I think we will get f of 3 is equal to 3 times f1, which is 3 into 2. Okay, now if I take n is equal to 3, then here we will be getting f of 3 square, and this will be 3 into f of 3, and f of 3 is 3 into 2, which I can write as 2 into 3 square. Okay, now this way I think we will be able to conclude, if I write this way, that f of 3 power, let us say k here, will be equal to 2 into 3 power k. If we keep on doing this thing, at least we have found the value of function for any n that is perfect power of 3. So let me call, this was equation number 3, let me call this as equation number 4. But this 2022 is not perfect power of 3. Forget about perfect power of 3, it is not even multiple of 3. Then how to do this? Now to do this, let me tell you, few more steps here will be involved. That we have found f1 as 2, we have found f2 as 3. Okay, now I think I can use this n is equal to 2 in this equation number 3 once again, and we will be able to get f of 6, and that will be equal to 3 into f of 2. F of 2 is 3, so that will be equal to 9. Okay, and here if you check f3, we found as 6. f3 we found as 6. Now tell me all of you that f3 is 6, f6 is 9. So what are the possible values of f4 and f5? Because my function is strictly increasing, and between 6 and 9 we have only two numbers, 7 and 8, and for 4 and 5 I think these are the only possible values. So this f4 has to be 7, because between 6 and 9 we have only two values, 7 and 8, and 4 has to be greater than f3, f4 has to be greater than f3, and f5 has to be greater than f4. So, and f5 also has to be lesser than f6. So I think these are the only possible values for f4 and f5. So far we have found f1, f2, f3, f4, f5, f6. Now if we need to find f7, I will be again using this equation number 1. How? In this equation 1, if I put n is equal to 4, okay, I think we will get f7 is equal to 12. If I need 8, f8, if I will be putting n is equal to 5 in this equation number 1, so f of f5 means f of 8 will become equal to 15. So you can see we have found f7 also, f8 also, f9 we have already found. But now the problem is that, is this how we are going to do it? because till 2022 if we go on this way, I think it is going to be huge. And one more thing what you can check here, that values are not all like f1 is 2, f2 is 3, f3 is then 6. There is a gap of two numbers, 4 5 are missing. Okay, then f4 if you check, it is 7, f5 is 8, f6 is 9. So these four values were continuous. f3 was 6, then 7, then 8, then 9. But then f7 was not 10 or 11, it is 12. f8 is 15. So how we are going to conclude that what will be exact formula? Now please listen carefully how we are going to do this. We have found already that f of 3 raised to the power k is equal to 2 into 3 raised to the power k. This is my equation number 4. Now if I put n is equal to 3 power k in equation number 1. Equation 1 means here. So that means I will be getting f of 3 power k, and this will give you f of 2 into 3 power k, and this will be equal to 3 into 3 power k. And let me call this as equation number 5. Now everybody please see, 3 power k to 2 into 3 power k, between or inclusive of both 3 power k and 2 into 3 power k, you can see the numbers are exactly same as that in 2 into 3 power k to 3 into 3 power k. This equivalent sign I am using for numbers, that between 3 power k to 2 into 3 power k, we have same number of numbers which we are having for 2 into 3 power k to 3 into 3 power k. Okay, so doesn't that mean that because this relation f of n plus 1 greater than fn, we need to have exactly one option for any number that is lying between 3 power k to 2 into 3 power k. Let me write it here this way. So f of 3 power k plus r will be equal to 2 into 3 power k plus r, where this r is less than or equal to, let me write with 0, and less than or equal to 3 power k here. And in fact you can check for r equal to 0, r is equal to 0, it is matching for equation number 4. And if I take r is equal to 3 power k, then also I think it is matching. So we have got, let me call this as another equation number 6. And let us go to one more slide. And let me repeat what we have done so far. We have got f of 3 power k is equal to 2 into 3 power k. This was my equation number 4. Then I got f of 2 into 3 power k to be equal to 3 into 3 power k, and that was my equation number 5. Let me check. Yes, it is so. Now what I have proved once again, one more thing, and that is f of 3 power k plus r would be equal to 2 into 3 power k plus r, where r is between 3 power k to 0, and both can be considered to be inclusive, because that then equation 4 and equation 5 are also matching. Now if you see that we have done for 3 power k to 2 into 3 power k, but what about when my numbers are from 2 into 3 power k to 3 into 3 power k? I think that is what we need to think of. Now once again, I think this equation number 1 is going to help us in for this thing. Please see how this equation 6, if you check on the right hand side, the value is actually of this form only, 2 into 3 power k to 3 into 3 power k, because my r is lying between 0 to 3 power k. So if I put n is equal to 3 power k plus r in this equation number 1, okay, so f of fn will be actually f of 2 into 3 power k plus r, okay, and that has to be equal to 3 into 3 power k plus r, and this is my equation number 7. So you can check, this will again work for r from 3 power k to 0 here. Okay, and if values are repeated, if you're getting same value for equation 6 and 7, I think answer is also same. Like if you put r is equal to 3 power k here, and if you put r is equal to 0 here, you are getting same answer for both of them. If you put r is equal to 3 power k here, we will be getting 3 into 3 power k, and here also we are getting 3 into 3 power k. So I think we have got the complete values for this function. Now we have to find what is my f of what is my 2022 number. Now 3 power 6 is I think 729. Okay, if I multiply this by 2, this becomes 1458. And 3 power 7, or let me write 3 into 3 power 6, it is 2187. 3 into 3 power 6 is 2187. So definitely 2022 is going to lie between 2 into 3 power 6 to 3 into 3 power 6. That is, it will be, lying, that will be given by equation number 7. Okay, now we have to find correct value of r, and for that what I am going to write, I will be writing 2022 as 2 into 3 power 6 plus 2 into 3 power 6 is this, and plus if I need to do, I think I'll do the subtraction here. 12 minus 8 is 4, 11 minus 5 is 6, and 9 minus 4 is 5. Let me check once again. 4 plus 8 is 12, and 7 plus 5 is again 12. 6 plus 4 is 10, 0 here, and 1 plus 1 is 2 here. That is how we can write this as. So you can see that f of 2 into 3 power 6 plus 564, that is what we are looking for, will be 3 into 3 power 6. Okay, and r is 564. So this we can solve to get the answer. Okay, 3 power 6 is 729 plus 564. If I add this, we will be getting 3 into 3, 13, 3 plus 6, 9, and 7 plus 5, 12. And I hope I am not wrong. 9 plus 4 is 3. This is 3 here. 7 plus 2, 9. 5 plus 7 is 12. Yes. So this will become 9 here. 3 9s are 27. 3 2s are 6 plus 2, 8. And I think it will be 3 here. So 3879. 3879 is the answer. 3879. So I hope you would have liked this question and solution. Very interesting question. Please think this question once again after you have gone through it. Once again, try it yourself. Now coming to this question which says f0, 1 to 0, 1 be a continuous function such that f of fx is equal to 1 for all x lying in 0, 1, then we are given 3-4 options and we have to find which one of them is R2. Now please understand that from this relation what we can conclude, that for any x1, let us say, that belongs to the domain 0, 1 which we are given in this question, the range, the value corresponding to this fx1, that will be lying in the range, and that will also be lying in the same interval 0, 1. Now, because this element that is lying in the range, will there be in this domain also? And if I consider this element in the domain and I try to take the value of function at this f of fx1, then it has to be 1 from this relation. So what important thing I have concluded from this is that whatever elements are there in the range, if you consider them in the domain, the value of the function at all those elements has to be 1 only. Just to give you one example, suppose my range is, and for that first let me tell you, range should include 1 for sure, because f of fx is 1, and also it is a continuous function. So let me take that if range is from, let us say, half to 1. In that case, for all x that are between half to 1, the value of function has to be 1 only. And for those x between 0 to half, the value will be between half to 1, but this graph may go like this also. All values for x between 0 to half may not be 1, they may be some other values also, and because range is half to 1, so it may go like this, or maybe it may go like this also. Okay, so this is something that we have to understand for this question, that this will have one value at multiple x. So we can conclude it has to be many one. Also you can think of either it will have only value as 1, okay, then also it has to be many one, because for all values of x belongs to 0 to 1, if 1 is the only value in the range, then it is many one. Or if it is having, let us say, two different values in the range, and these two different values are fx1 and fx2, and these are two different values in the range. Assuming that 1 is not the only value in the range, we have two different values, and then you can see f of fx1 and f of fx2, they both will have to be equal to 1. So this function is definitely many one. Now coming to this B part, which says this graph of y is equal to fx will intersect the line y is equal to x for some x belongs to 0 to 1 open bracket. Now in one of these scenario, I may take that fx is always equal to 1. Then this graph will be like this. And in this case, you can check that y is equal to x line will be like this. It will intersect this graph, but at x is equal to 1. But if there is an open bracket at x is equal to 1, then it will not intersect. So A is correct, B seems to be incorrect. Now coming to C part, which is asking that 0 to 1 fx has maximum value to be 1. I think in order this to have maximum value, we need to make sure that area of this graph of y is equal to fx between 0 to 1 is maximum, or you can say it should be at maximum height at all possible values of x. So that maximum height can be 1 only, because its codomain is 0 to 1. So I think this maximum area will be when we take this kind of function only, that is y is equal to that fx is equal to 1. So this A max area max will be equal to 1, and hence this C seems to be correct. Now coming to this D part, 0 to 1 fx dx can be less than 3 by 4. Now to do this question, we need to find what can be the minimum possible value of this area. And to do this, let us take that range B. Earlier I took half to 1, now I'll take a comma 1. A comma 1. That means from a to 1, the value of function will be throughout 1. Okay, and between 0 to a, the value should be somewhere between a to 1. But if I want this area to be minimum possible, okay, there can be multiple ways to draw this graph. One of the possible way can be this, but in order to have minimum possible area, I think my graph should go like this. Okay, from a, this point here, to this point here, it should go vertically or horizontally, and then after this it should go almost vertically. It cannot be vertically, because otherwise at A you will have multiple values, but in order to get minimum possible area, we can assume this to be vertical. Okay, and that will be minimum possible area for any range that is from A to 1. Okay, in this case, what will be my area? You can check here. This height is A and this is also A. So this minimum area, or this minimum value of this integral will be A square here, A into A, and here this will be, I think, 1 minus A, and this height is 1. So here we will be getting 1 minus A. So this A minimum will be A square minus A plus 1. In fact, if I have liberty to choose different values of A, then A absolute minimum will occur when we choose A as half. And when A will be half, I think we are getting this to be equal to 3 by 4, when A will be equal to 1 by 2, because it's a quadratic upward parabola, minimum value will be at a is equal to half. Okay, but this 3 by 4, as you can see, is not possible, because this will be possible only if this portion of graph is completely vertical. But in that case, it will not be a function. We have to keep some slope here, and if we keep some positive slope here, then this value will be less than 3 by 4. You can only have an open bracket at 3 by 4, but it cannot be equal to 3 by 4. Less than 3 by 4 is out of question. So saying it will be less than 3 by 4 is not possible. Okay, now one more thing I thought of, that I took range to be a to 1. Is it possible to have range in two different parts? Let us say some a to b and then say c to 1. Is it possible to have this kind of range? If that will be the scenario, suppose this is 0, this is a, this is b, and this is c, and this is 1. Okay, in this case c to 1, this graph should be equal, will be like this only, parallel to x-axis, having all values to be 1, and from a to b also it should be like this. Okay, now my a will be here, b will be here. Let me make this graph once again, or let me, I'm saying that range is a to b union c to 1, a to b here and c to 1 here. So what will happen if we are going to have like this, that for 0 to a, values will be from a to b somewhere like this, and then between b to c we are not having any value, so we have to make a jump from this point so that my values are from c to 1, and that seems not to be possible if this function is continuous. So this kind of thing is not possible. I think the possibility is that you have range in one continuous interval like this that I have taken. So this completes this solution of this question. Now coming to the next question, we are given that read the following write-up carefully and answer the following questions. Consider function f r to r, and we are given f of x square plus y into f of z equal to x into fx plus z into fy for all x, y, z belongs to r, and fx is equal to 0 is not considered as part of solution set. Then see how we can do this question. First of all, if I take x and y to be 0, 0, okay, then this left hand side will become f of 0. Whatever fz it is, it will become 0. On the right hand side, this will be 0 here plus z into f0. Now, I can choose z to be any number. So in order this to become true, I think you can see it will be z minus 1 into f of 0 is equal to 0. So that means f0 has to be equal to 0, because I can choose z to be any real number. It need not to be equal to 1. So f0 is 0, that we have concluded. Number 1. Number 2. Now if I put x is equal to 0, okay, we will be getting f of y into f of z is equal to z into f of y. Now if I take f once again both sides, so f of f, y of fz, it will become f of z into fy. Now make use of this relation number 2. You can think of that we can interchange y with z, then this f of z into fy will become here equal to y into fz. Just equation number 2 we are going to use. You can think of that y and z has been replaced, then f of z into f of y will become equal to y outside, z inside. But here you can see y into f of z is here also. So what we have obtained here is that f of f, let us say t, is equal to t here, where t is equal to y into f of z. And it can be any real number once again. See, if fz is not 0, and y can be taken from minus infinity to plus infinity. So this product will also be from minus infinity to plus infinity. I can choose fz to be non-zero because we are given that taking fx is equal to 0 for all x is not considered as part of solution. So this t will also be equal to, t can also take values from entire real number. So what we have proved that for all t belongs to R, f of t will become equal to t. This is something we did in our first question also. There it was 3 times f of f. Here it is 2 times. Now, how we can make use of this thing? Once again, please see. If I take, let us say, y equal to 0 in this given relation, I will be getting f of x square is equal to x into fx only, because fy will be 0 and here this is 0. Now if I take f once again, so it will become f of fx square is equal to f of x into fx. Now we have proved that this kind of thing will become equal to x square from this equation number 3. And if I make use of equation number 2 once again and saying y and z, they both are equal and equal to x, then we can write this also as x into fx. So from this we have obtained what will be my fx. I think this is coming out to be x only. Although this we would have guessed from this also, but there are always chances that we may get some other solution, but now we can say with full confidence that that is the only solution. So you can see that f alpha will be equal to alpha, and between 0 to 1 I think alpha will be greater than alpha power 4. So this is not correct. You know that thing, that if number is between 0 to 1, if you raise the power it becomes lesser. Same will be with b also, this is also wrong. Okay, now for alpha belongs to R plus, f alpha is equal to alpha q is definitely possible, because that means alpha is equal to alpha q. I think we can get alpha as one of the solution. So C is definitely correct. Now f alpha is alpha, so this limit will be 1 only. Okay, and sine alpha upon alpha is also 1. So both sides limits are coming to be 1. Both sides limits are coming out to be equal to 1. Now please listen carefully, there can be some confusion here. Some people think that sine alpha upon alpha is less than 1. Although here there is no confusion, because this is absolute 1 and sine alpha upon alpha is lesser than 1 for alpha approaching to 1 positive. So this less than sign is wrong. So D is also not correct. So only correct answer is C here. But I was about to tell you something else, that even if we have to compare these two things, let me tell you, this will also be considered as perfect 1. Whereas as alpha approaches to 0 plus sine alpha upon alpha, we will think of this entire thing separately. Okay, because limit alpha approaching to 0 plus, limit alpha approaching to 0 plus is written separately on both the expression. So I will find this limit first, I will find this limit also first, and then we will compare them. So these two things will become equal actually. So if someone would have given this like this, then I will say this is correct. Okay, I hope you are getting what I'm trying to tell. Actually, if it was given like this, that limit alpha approaches to 0 plus and f alpha upon alpha is less than or equal to sine alpha upon alpha, please see. If this was given like this, where alpha is approaching to 0 plus and both of them are compared for every alpha that is approaching to 0 plus, you can see always sine alpha upon alpha will be lesser than this, because this is absolute 1, whereas this will be lesser than 1. I hope you are getting what I'm trying to tell. Here both are having same limit 1 1, so they can be equal, they will be equal actually. Okay, so but because they were not this equal to sign, so answer will be only C. Okay, now this is the time for teaser question, but before that, dear all, Vedantu Eklavya is for JEE Advanced preparation in online domain, and this is one very big thing from Vedantu. So if you are targeting for JEE Advanced next year or next to next year, please be aware about this thing. Just Google it, you will come to know. I'm sharing with you the link of topper notice board, where we will be sharing with you all information regarding new batches coming up or new things going on in them. You can scan this QR code, and in fact these things are shared in your description box also. Now those who will be appearing for JEE Advanced in 2023, please click on this link. You will be part of Telegram channel, where we are going to put all important information regarding Eklavya batch for 2023, and same for 2024. Dear all, this V Impact YouTube channel is where we have put solutions for JEE Advanced, KVPY, ISI CMI. Actually, they are under process. They will be very soon put in that YouTube channel, and these solutions are put question wise. So please visit this channel to get solutions of these questions. In fact, we have given multiple solutions also. Now coming to teaser question today here is that we are given a function f n to n satisfying this condition that x minus fx is equal to 19 times greatest integer function x upon 19 minus 90 into gent of fx upon 90, and also f of 1990 is between 1900 and 2000, strict inequation both sides. You have to find what is the value of f of 1990. Okay, so if you have got the solution of this question, do not forget to send the solution at this email ID with the subject line teaser solution maths. This email ID is eklavyaSupport@vedantu.com. We will be checking your solution, and if we like it, we will reach out to you on the same email ID through which you have sent the solution. You keep on sending the solution. Sometimes we will be reverting you with 2 or 3 solutions when we will be receiving from you. So please keep on sending them. Okay, so that is all for today. Thank you so much. That is all for today. Bye everyone.